Hi everyone, this is Module 2B, Example 3 on page 36 of your activity packet. So the list below are commute travel times measured in minutes for 20 randomly chosen workers in downtown San Francisco. And you can see we have quite a range here, from 5 minutes all the way up to, it looks like 70 minutes or maybe even higher. So part A asks us to find the median. So we know from the last example that the median is the midpoint. Or make a stem plot down below. I'm going to actually go ahead and use Excel. So if we go into Excel, and sheet 3 lists all this data, and you can download this data file in Desire to Learn. And then I'm going to do our favorite sorting of the data. And we like to go smallest to largest, so ascending order. So we can see it starts at 5 and ends at 72. There's 20 values, so we know the median must be between the 10th and the 11th values in the middle. And so it looks like that would be 48.5 right in the middle. Another way you can check it is in Excel, over in some other cell, we can say equals and start to type in a formula. And we can type in median, and then in parentheses, we want to put our range. So our range is from A1 to A20. These are our cells. And if you type it just like this and hit enter, it verifies what we noticed, that our median is 48.5. And I'm going to go ahead and label this as median so you guys have that data there. So now the next thing they're asking us for is the mean or the average of the commute times in part B. So to find the mean, you can add all the data together, and then we divide in this case by 20 because there's 20 data points here. So you can get out your graphing calculator and crank that out if you want. A faster way, of course, is to let Excel do the calculations for us. So over here in column C, row 3, it doesn't matter where you do it, I just chose a spot. I'm going to type another formula, and I'm going to say equal sign, and you'll notice the formula starts to pop up here in the formula bar. And then I'm going to type mean. You may have to type average. We'll see if Excel will process mean for us. And I'm going to type again A1 through A20 using the semicolon. Oh, and see how Excel doesn't recognize mean? This is a good example of sometimes Excel uses different names for functions. So instead of mean, we need to type average, which is the word Excel uses to calculate the average. And so we can see here, here's the mean at 44.35. So part C is asking, how does the mean compare to the median? What's larger or smaller, or are they pretty close? So in this case, the mean is smaller than the median. So let's go back to example 3 and note this down. The mean is smaller than the median. Then we can say the mean is, what, 44.35, and the median is 48.5. The next step is asking us to make a histogram and to count our bins by tens, and then describe what the distribution looks like. Let's go ahead back to Excel and do that. So remember, you may need to type the bin sizes here in Excel in another column. It doesn't matter which column you do it in. Because I'm on the Mac, I have downloaded the Better Histogram program. So I'm going to highlight A1 to A20 and go Tools, Better Histogram. And then my data range, I need to type in A1 to A20. And we want to start at 0, go by tens, and we want to go all the way up to 80. And again, we don't really need to start at 0. We could actually start at 10. And here is our histogram. So if we look at our shape, which we want to describe, it looks like it's pretty steady, and then it has a peak from 60 to 70 and dips down at 80. It's definitely flat from 30 to 60, and we wouldn't call this a symmetric graph. It looks like the tail is actually going to the left. Okay, and remember our units are in minutes, so I'm going to go back up here and make sure that I label these as 48.5 minutes and 44.35 minutes. So don't forget to include units in your answers. You want to get those habits so that when I'm grading your test, I don't have to take points off for forgetting units. In this example, what do you see as a relationship in a left tail histogram between the mean and the median? So this is a left tail histogram, and the median was greater, or the mean was smaller. Either way. So because the mean is lower, let's talk about what that means in terms of the histogram. That lower mean or lower average means that there were more low values, that when we totaled everything up and added and then divided by the 20 times total, that there were more low values pulled down the mean, if that makes sense. So the average is being pulled down by these large number of low values. There is a peak between 60 and 70 minutes, but overall, if you count up how many people fell below that, there's more people below. So you get a left tail when the mean is pulled down by values that are smaller. Okay, this is example 4 on page 36 now, or page 37 now. So here we're going to compare commute times for randomly chosen workers in downtown Concord. And so Concord may be a place where people live more close to their job. We'll find out looking at the data. So if we go back to Excel, this data is in sheet 4. And the first question asks us to find the median. So I'm going to first reorder the data. Oh, and see if I click sort, see how it automatically did it in descending order. I actually want it ascending, smallest to largest. So I'm going to click sort again and see how it shifts it for me. Then we want to calculate the median. So we can put over here in one of the cells our formula equals median. And then our data goes from A1 to A20. And our median is 18 minutes. Now we want to find the mean or the average. And remember, in Excel, we have to actually type in average. And then in parentheses, we can put our data range, A1 to A20. And we found our average is 22.4 minutes. So in this case, how does the mean compare to the median? Well, in our example, the mean is larger than the median. So let's go ahead and take a note on page 37 of that. So the mean, which is 22.4 minutes, is larger than the median, which is 18 minutes. So we're going to go ahead and make a histogram in Excel now. Again, our bin sizes are going to be from 0 to 60, counting by tens. So I'm going to go Tools, Better Histogram, because I'm on a Mac. Remember, if you're on a PC, you're going to go to Data Analysis and choose Histogram and Data Analysis tab. So we want to start at 0, count by tens, and stop at 60. And here's our histogram, and it looks like our histogram has a peak between 10 and 20 minutes, and then it's got a tail to the right. So in this example, what's this relationship? We had a right tail histogram, and in this case, the mean was larger than the mean. Or I should say greater, maybe that's the word that we use in the packet. So this example has a right tail histogram, and the mean is greater than the median. So let's go back to Excel and look at the graph and think about what this means. So this means that there are a few very high values that are pulling the average up. Does that make sense? So a few people have very long commutes, but they're so long that they pull the average value higher over here in the right direction, and that's why we see the right tail on the graph. This is example 5 on page 38. So based on these previous examples, we made some conclusions about tails and the relationship between mean and median. So let's go back and review those conclusions that we made. So here in example 4, we concluded that there was a right tail histogram and the mean was greater than the median. And I showed you on the graph that means the right tail is pulling the average and the mean up. In example 3, part E, we said this is a left tail histogram and the median was greater and the mean was smaller. So in this case, I said the small values were pulling the mean down. So one way I remember this is if the mean is smaller on the left side of the median, then you're going to get a left tail. And if the mean is greater or on the right side of the median, then you're going to get a right tail. So you can think that the tail goes whichever way the mean is pulling it. So question A in example 5 asks, which of the following distributions is likely to have a mean that is smaller than the median? Why? So example A is repeated measurements of the volume of a soda in a 1 liter bottle. Well, I would expect that to be pretty uniform or standard. Question B is the scores on an easy exam in which most are A's and B's but a few are F's. Okay, so if mostly A's and B's, then the scores are going to be higher, and this is going to have a few F's pulling it down. So this is going to have what we call a left tail because there's going to be a few low values, or low scores, we could say. C, salaries of Major League Baseball players. Well, in Major League Baseball, there are a few players that make high salaries. So this would be a right tail because a few players have high salaries. So we want to know which one has a mean that is smaller than the median. So remember, if the mean is below the median, that's going to pull the tail to the left. So this would be example B. And so we can type up here. Oh, I want to make a circle. I'm going to go ahead and circle example B. Okay, there I circled example B. So we're going to say here, example B would have a left tail because there are a few low scores in the class. And this would result in a smaller mean. Okay. Question B is asking about a news article that reports that of the 411 players on a National Basketball Association roster in 1998, only 139 made more than the league average salary, which is 2.36 million. So they're saying this average is loosely used, and both the median and the mean are a measure of the average of the center. So two different ways to think about the center of a graph. So is the 236 going to be the mean or the median for the NBA players? The 2.36 million. So it tells us only 139 players made more than this 2.36 million, but there were 411 players. So the median would fall in the middle. The median would be the salary of the middle would be the 206 player, I think. If only 139 players made more than 2.36 million, then this must be the mean. Does that make sense? Because the median would be right in the middle, but only 139 players were making more. So this is an example where the mean of 236 million is above the median and might not be representative of the basketball players. All right, and I think we answered our part C here. We could make a note that because there are a few players with high salaries, basketball players' salaries will be a right tail graph. And we know that means the mean will be greater than the median.